Welcome back, MEFB 2132013 manufacturing processes. So let's continue. So we were talking about materials. So a very most important factor in your final product is the selection of materials. So if you select the wrong material, instead of having a very aesthetic design, high quality, the product will eventually fail because of the wrong selection of material. The material has to be suited to the application of the material. So how do you know if you're using the right material? Okay, so different types of application will need different types of characteristics of material. For example, if it's in a high heat environment, you may need to use or have a material with high melting point. If it's going to need a high impact, then you probably need to use a material with high tensile strength. So it all depends on the product application that will decide the material selection. So if you remember, in the last class we spoke about the three main materials, the three categories of materials: metallic, non-metallic and composite. Metallic is divided into ferrous and non-ferrous. Non-metallic is divided into organic and inorganic. And finally we have composite. We have not touched on composite yet, so let's look at we spoke about the pros and cons here. What is the advantages of ferrous material? It's high in strength. Disadvantages: low in corrosion resistance. What is the advantages of non-ferrous material? It's high in corrosion resistance, but disadvantage is low in strength. As for organic, you know, it's made of animal or vegetable cells. It is readily available. Advantage: it's readily available. Disadvantage: it only can be dissolved in organic materials to process. So organic liquids are like ether, alcohol, which is very expensive. Secondly, organic materials has low melting point, meaning that it would not be able to withstand high heat. Okay, so opposed to that, inorganic materials are man-made. For example, ceramics, polymer, plastics, glass. Okay, so if you look at it, the advantages are these materials has high resistance to heat, so it can be used in high temperature applications. However, just like any other materials here, it also comes with some disadvantages, that it is not readily available, so it needs to be processed. Before it transform, you need to go to several processing, severe processing before you get your material, and then only you start your processing. So and by the way, inorganic materials are made of are man-made, meaning it's not made of any, it's other than animal or vegetable cells. Okay, so let's look at the engineering properties of materials. So you have tensile strength, compressive strength, torsional strength, modulus of elasticity, and hardness. Okay, so what is tensile strength? Tensile strength is the ability of a material to support or carry an applied axial load. Okay, so first of all, how do you evaluate material? How do you know that this material is suitable for this product, this material is suitable for this product? We have something called an engineering properties of the material. So when you one day become an engineer and you're given a task to do selection of material by your superior, so first of all, you're not going to do it by multiple choices, by okay, this material looks nice, I think I will choose this material, or this material is attractive, I will choose this material. It's not based on attractiveness. You need to choose your materials based on the engineering properties of materials. So when the project comes in, or the job comes in, the vendor has already, or the user or the manufacturer has already specified, okay, you need to manufacture this product whereby this product needs to have high tensile strength because it's going to be used in a high impact environment. It needs to have high melting point because the temperature around there is maximum 200 degrees Celsius, and it also needs to be of high hardness. So all the characteristics has been outlined when the request to manufacture the product is handed in. So you as an engineer, be it a materials engineer, manufacturing engineer, line engineer, okay, so when you get the code or the job, first of all, you need to go and look up the engineering properties of a material. So what does this engineering properties of material tell you? It will tell you, okay, material number one, cast iron, the tensile strength is how much, the compressive strength is how much, what is the elasticity of modulus, what's the hardness. So you're going to look at a few options that is going to suit your product, and then you slowly narrow down the scale. Where do you get these engineering properties of materials? Or if any one of you have the engineering handbook, yes, you can find it in the engineering handbook. Okay, so that's how you evaluate a material characteristics, and that's how you are going to select a material for the production. Like I told you, if you make the wrong choice, your product may look so attractive, but during testing the product will fail. So despite having an exclusive product, if the product fails, your entire manufacturing processes fails, your entire production fails. Therefore, you need to redo the whole thing again. So before that could happen, you need to run a trial run and see if the product is going to function, and then only proceed with the further manufacturing if the product is functioning well. So let's look at the engineering properties of material. You have tensile strength, compressive strength, torsional strength, modulus of elasticity, hardness, density, fracture toughness. There's so many, yeah. So let's look at some of it. Okay, so what is tensile strength? Tensile strength is the ability of material to support or carry an axial applied load. So when you apply load from both sides in the opposite direction, you stretch the material. When you are stretching the material, that is tensile strength. So you will find that there will be weakening at this point. We call this a dog bone. Yeah, normally for testing, we would use a material, a dog bone material. So when you stretch the material, it elongates. There will be some kind of weakening happening here. So as you keep increasing the stretch, okay, as you keep increasing the stretch, you find that the material starts weakening in the middle, and as you stretch and stretch and stretch, the material becomes thinner and thinner and will finally snap at this region. Okay, so that is tensile strength. To measure tensile strength is conducted by pulling on two ends as shown in the above diagram. Okay, so the results are described by determining the changes that take place in the length as the force increases to the breaking point. So a curve can be plotted for two values, stress and strain. So how do you evaluate the material characteristics? You're going to use a stress strain diagram. What is a stress strain diagram? Yeah, stress strain diagram basically will tell you how your material will behave before failure. How will your material behave before failure? So you have two types of failure. Yeah, you have the ductile failure and you have the brittle failure. What is the ductile failure and what is a brittle failure? Let's discuss this in a while. Okay, let's look at the other engineering properties. So you have Young's modulus of elasticity, which is an indication of the stiffness of the material, where E is your elasticity of modulus. This is your sigma. Yeah, sigma is your stress, and this is your strain. Okay, so that's how you use to calculate the elasticity of material. Then you have something called shear stress. is the result of parallel forces known as shear angle or shear strain, and G is defined as the shear modulus or modulus of rigidity. So modulus of rigidity G equals to E over 2 plus 1V. I don't expect you to memorize this formula, but you definitely need to know three formulas which I will highlight shortly. And obviously, when in the real engineering world, whenever you produce a material, you must be able to calculate the factor of safety. Factor of safety is defined as the ratio of the actual stress to the allowable strength of the material. So factor of safety is stress actual over stress allowable, and the recommended factor of safety range is from 1 to 3. So if when you calculate factor of safety based on the actual stress over the allowable stress and the value exceeds 3 or it is below 1, we consider the material not safe for production. So you need to stop and go and re-look at the material selection, because that deems that the material is not suitable for this particular application. Okay, so at the moment we'll stop here. Thank you very much, class. I will upload another presentation shortly.